All right, it's time for rational approximations. It's called approximations because it's not asking you to be perfect. It's not asking you to calculate each one of these exactly. Number one says identify the missing symbol, and your choices are equal, less than, or greater than. So is the square root of 185 minus the square root of 8 less than, equal to, or greater than pi squared? You don't have to know what all of these are exactly. You're supposed to approximate. So let's look at each one of these things and approximate what they are. The square root of 185. I don't know what the square root of 185 is, but I do know the square root of some perfect squares because I know what, for example, 12 times 12 is. 12 times 12 is 144. This is more than 144. Well, the square root of it anyway. If the square root of 144 is 12, the square root of 185 is clearly more than that. 13 times 13 is 169. That is clearly more than the square root of 169. So this number is clearly more than 13. 14 times 14 is 196, but 185 is less than 196. So if 14 times itself is 196, the square root of 196 is more than, the square root of 196 is 14. The square root of 185 then is less than 14. So what we know is that this number is between 13 and 14. It's a little closer to 14, so let's just round this off to 14. The closest perfect square to 185 is 196. So let's just kind of pretend it's 196 for now, because we're approximating. So this is about 14. It's a little less than 14. What about the square root of 8? What's that close to that we can actually take the square root of nice and easily? Square root of 8 is really close to square root of 9. It's a little less than the square root of 9. Well, square root of 9 is 3. So this is about 14 minus 3. That's what we're looking at right here. It's not exactly 14. It's a little less. We're not taking away exactly 3. We're taking away a little less than 3. But if it was 14 minus 3, we'd get 11. So this has got to be something close to 11. So the left side of this is about 11. Well, what about the right side? 3.14 is what pi is, about close to 3, a little bit more than 3. If we do pi squared, then what we're doing is 3.14 times itself. That's a little bit more than 3 times a little bit more than 3. Well, 3 times 3 is 9. So this is going to be a little bit more than 9. This is about 11. This is a little bit more than 9. So the left side's greater. So again, for all of these questions, you don't have to calculate these all. You don't have to punch them into a calculator. It's trying to get you to use your approximating skills. Know what the square roots of perfect squares are, which means you have to know what the perfect squares are. See if your irrational numbers that you're getting that are square roots of non-perfect square integers, see what perfect square integers those are close to that you could actually take the square roots of. And then things like pi, you just kind of know what pi is, and pi is about 3. You know what 3 times 3 is. So that's how you do problems like that. Let's do another one. Use the number line to correctly compare the numbers, compare the following numbers. So again, we have pi. It's a popular irrational number. And again, pi is about 3. Well, 3 divided by 2 is 1.5. So pi divided by 2 is going to be close to 1.5. It'll be a little bit more since pi is a little bit more than 3. Well, what about 14 fifths? Well, 14 divided by 15 divided by 5 is exactly 3. So 14 divided by 5 is less than 3. So this is more than 1.5, a little bit more. This is a little less than 3. And then finally, we have the square root of 5. Well, I don't know what the square root of 5 is, but I know the square root of 4 is 2. So the square root of 5 is a little bit more than 2. So this number we have is a little bit more than 2. This number is a little bit less than 3. And this number is about 1.5, a little bit more than 1.5. So on the number line, pi divided by 2 is less than the square root of 5, which is less than 14 fifths. So which one of those says one of the things that we just discovered? Well, this one says that pi divided by 2 is greater than 14 fifths. But again, pi is about 3. So 3 divided by 2 is about 1.5. 1.5 is not greater than something that's almost worth 3. So that's not true. This one, again, 14 fifths is almost 3. It's a little less than 3. And the square root of 5 is just a little bit more than 2, since the square root of 4 is 2. So there's not something that's a little less than 3. It's not more than something that's barely more than 2. So this is also false. This one, finally, the square root of 5, which again, a little bit more than 2, is greater than 14 fifths. Nope, that doesn't make sense either. That's the exact same thing that this one says, just backwards. Now we get down to D. Pi divided by 2, that's the smallest thing, is less than 14 fifths, which is the largest of these three options. 3, choose a statement that correctly compares the two numbers, the square root of 170 and the square root of 171. Well, obviously, the square root of 170 is less than the square root of 171. What are they getting at here? Let's read. A, the square root of 170 squared equals 170, and the square root of 171 squared equals 171. Since 170 is greater than 171, the square root of 170 is greater than the square root of 171. The square root of 170 is greater than the square root of... This is not a trick question. This is just nonsense. Why would 170 be greater than 171? It's just testing your common sense at this point. You definitely want the one that says that 170 is less than 171. So take a look at the options that say that. B says 170 is less than 171. C says it's 170 is greater. That's nonsense. D says 170 is less than 171. So it has to be B or D. But note that over here, it says that the square root of 170 is greater than the square root of 171. Again, nonsense. It's not a trick question. The smaller numbers are worth less. Number 4, determine which two values the following expression is between. So I've got the square root of 5. Now the square root of 5 is a little bit more than 2. I know that because the square root of 5 is a little bit more than the square root of 4. And the square root of 4 is 2. This says 2 times that. Well, 2 times 2 is 4, and the square root of 4 is 2. So we're doing 2 times a little bit more than 2. But all of these options are that same thing. So what we're going to do here is we're going to unsimplify this fraction. And here's what I'm talking about. If you take the square root of 2, or excuse me, square root of 5 times 2, that's the same as saying the square root of 5 times the square root of 4, because 2 is the square root of 4. Let's write it down so that you can see it a little bit more clearly. Get my drawing tools out here. I'm going to ask you to forgive me in advance for my messy handwriting with my mouse here. But here it is. I'm going to replace this 2 with something that it's equal to, the square root of 4. So I've got the square root of 4 here. Now I'm going to multiply, so times the square root of 5. Now, did I just change what we see up there at all? I didn't change the value of it. I just changed the 2 into the square root of 4. You know the square root of 4 and 2 are worth the same, so I didn't actually change anything. 2 times the square root of 5 is the same as the square root of 4 times the square root of 5. Well, if you have 2 things under a square root symbol, you can multiply them together. If they're multiplied together, you can put them, the product of them, underneath just one square root symbol. So the square root of 4 times the square root of 5 is equal to the square root of 20. So this answer is equal to whatever the square root of 20 is. So all you have to do to figure out what the right answer here is which one of these, if you multiply it by itself, is less than 20, but the very next number is more than 20. That's pretty much it. Now, obviously, if you're using a calculator here, you just take the square root of these two things. But, oh man, do you know how to do that with this calculator? This scientific calculator that I was using earlier for a different problem doesn't have a square root symbol. I mean, you could do it with an exponent if you know that an exponent of 0.5 is the same as taking a square root. But we haven't covered that yet. If I take 20 and I use an exponent of 0.5, that is equal to 4.47. So this number is more than 4.47, because obviously after the 4.47 there's more digits. So it's between 4.47 and 4.48. The answer is D. But how would you do that if you didn't know that the square root of something is the same as raising it to an exponent of 0.5 or 1/2? Well, this particular calculator that comes on my PC is a standard version, and this button is the square root button. So you have 20, and you have the square root button, and there you get the 4.47. But a lot of you guys use Google, and a lot of times if you have Google, you might have something like square root 20, SQRT. Oops, I just put 2 instead of 20, so I'll have to type that in again. Square root, SQ for square, RT for root of 20. And that is how you type in square root in the Google calculator. The Google calculator also has this symbol right here. That's the square root symbol. So if I have 20 and I hit this button, that would be the square root, but it makes you do it backwards. Notice that it has the square root symbol and then it starts opening parentheses. So if you're using Google calculator and you want to find the square root of something, you have to square root the button first, then put the number in, then you can hit your equals button, and that gives you your answer. So clearly we have the square root of 20 as more than 4.47, but less than 4.48, and that is our answer. Number 5, which of the following is the best approximation for the irrational number shown below? Well, it's negative. So whatever we get out of the square root thing is going to be negative. That's good. All of these are negative. 176. What is the square root of 176? You can go ahead and use a calculator for this. I will let you. 176, hit the square root button, 13.26. So negative 13.266 would round to 13.27. If we're looking at these, negative 13.27 is a better answer because when we round to the nearest hundredth, we have to look at the thousandths place. And since this number is 5 or higher, we're going to bump up the 6 in the hundreds place to a 7. This is closer to 13.27 than it is to 13.26. So the negative version would be negative 13.27 if we're rounding to the nearest hundredth. Number 6, approximate the value of the square root of 2 to the nearest thousandth. First, complete the decimal values at the two ends of the number line provided. Then place a point on the number line to represent the approximate value of the square root of 2. So again, complete the decimal values at the two ends of the number line provided and put the point on the number line. So you notice that it goes out to the hundredths place. So it wants you to put the hundredths places, and then it wants you to fill in the dot for the thousandths place. So what is the square root of 2? You're going to have a calculator in your pocket the rest of your life. It's okay for you to use a calculator. If you have a phone, it has a calculator on it. Use a calculator if you want to. 1.4142. So if I'm going to the nearest thousandth, the 4 is in the thousandths place. The next number is less than 5, so I'm going to keep it as a 4. So 1.414 is what we're looking here. For. So if I go back to my thing, to my diagram over here, 1.41 and 1.42 is what it's between. It's between 1.41 and 1.42. What is it exactly? It's 1.414. So we go ahead and put that on the number line by taking this. That's 1, 2, 3, 4. So this would be 1.411, 1.412, 1.413, 1.414, and 5, 6, 7, 8, 9, all the way to 1.420. Number 7, place a point on the number line to represent the approximate value of 4 times the square root of 12. So 4 could be the square root of 16. The square root of 16 times the square root of 12. Well, what is 16 times 12? 16 times 12 is equal to 192. So this number, you can calculate it 2 different ways. You don't have to make it into the square root of 16. But I want to show you how to do this because you're going to end up having to go backwards. 4 is equal to the square root of 16. So 4 times the square root of 12 is the same as the square root of 16 times the square root of 12. The square root of 16 times the square root of 12 is the square root of 192. Because 16 times 12 is 192, the square root of 16 times the square root of 12 is the square root of 192. So if I want to know what this is, I can just take the square root of 192. And I get my answer, 13.8564, etc., etc. But that's not absolutely necessary. You can literally just take the square root of 12 and multiply it by 4, and you're going to get the same answer. Watch. 12 square root times 4 equals. And you get the same thing we had a second ago, 13.856, etc., etc., etc. So you don't have to turn this into the square root of 16. And you don't have to say the square root of 16 times the square root of 12 is the square root of 192, and then take the square root of 192. But you can, and that skill will come in handy later for some of the problems you're going to have to do. Now, 4 times the square root of 12 is 13.856. So let's go ahead and plot that. We're going to use our point. It says to the nearest tenth. So I'm looking at 13.8 in the tenths column, but the next number is 5 or higher, so I'm going to bump that 8 to a 9, and I'm going to do 13.9. Here's 13.5, 13.6, 7, 8, 9. Choose a statement that correctly compares the two numbers. I have negative 2 times pi, and I have negative 10. Well, pi is about 3. It's a little bit more than 3. Negative 2 times 3 is negative 6. So there's no way that negative 2 times pi is going to get all the way to negative 10. So negative 2 times pi is greater than negative 10. Remember, if you're in the negative side of the number line, you want to be closer to 0 to be greater. So negative 2 times pi is greater than negative 10. Let's look over here. Since pi is less than 5, which is true, right? Pi is less than 5. Let's just look at the very first of all of these. Pi is less than 5. So B and C are out. A and D say that pi is less than 5. Then 2 pi is less than 2 times 5, which is true. So negative 2 pi is less than negative 10? No, it didn't take into account into the negatives. Let's read what D says. Then 2 pi is less than 2 times 5, so negative 2 pi is greater than negative 10. That's our right answer. Number 9, determine which two values the following irrational number is between. So the square root of 22, just off the top of my head, I know the square root of 25 is 5. So this number has to be less than 5. Right away up here. Is it between 5.2 and 6.2? No, this has to be less than 5. Okay, it's got to be more than 4 and less than 5. The square root of 16 is 4, and this is clearly more than that, so this is clearly more than 4. The square root of 25 is 5. The square root of 22 is clearly less than that, so this is clearly less than 5. This number has to be between 4 and 5. Which one of these things says that? Well, 5.2 to 6.2, that's impossible. This is even more impossible. This is the only thing, I mean, I wouldn't even use 5.2 on there. That's ridiculous. But it's definitely the only option here that's available. It can't be between these, well, unless it was very close to 16, but the square root of 22 is closer to the square root of 25 than it is to the square root of 16. So this number is closer to 5 than it is to 4. So C is going to be our answer. Number 10, the value of the square root of 22 is between 4.6 and 4.7. Which of the following is a more precise approximation of the square root of 22? Let's go ahead and get our calculator out. 22, take the square root of that. We got 4.6904. So it's really close to 4.69. Let's see what we have here. It's more than 4.69, but it's less than 4.7. Which one of these says that it's between 4.69 and 4.7? Right there. So that's it. Not too hard. Use your calculator. You can lean on it. You don't have to always use your calculator and be perfect when you're doing these calculations, but you are allowed to use your calculator to help you with these. And when you do that, a lot of these are pretty simple. Reach out for help if you need it.